Hi, welcome back to Prototalk. Today we're on episode 2, and what I'm going to do today is run the Alto-scope through its paces. So we're going to put a bunch of functions into the scope, and then we're going to, play with the frequency counter. I'm going to show you what the functions look like on both the Alto-scope and what it looks like on an actual oscilloscope, and hopefully this will help us to gauge the performance of the Alto-scope. As of now, the Alto-scope samples at 150 kilosamples per second, and that should give us an effective bandwidth of 15 kilohertz. So hopefully today we'll play with some slightly fast signals. We'll try to put in about 15 kilohertz signal for you guys to look at, and we'll see how it looks. We might actually play with a little bit faster signals and just see how well it renders. I don't think it's going to be good, but we'll see. Anyways, let's get to that. Okay, before we get started, let's do a quick rundown of the buttons again, because I don't think I did a good job of it last time. All right, so this button here controls LCD contrast. This one here controls the menu system that's on top right now. It's on it's on the peak voltage and the trigger status, which is off. Now we got our voltage divisions and time divisions, and over here are the buttons that control that. So this controls the voltage division. If I press this, it should cut that in half, and let's see that happen right now. Yep, so it went from 1250 millivolts per division to 625, and let's press that again, and it's cut that into 3 parts. So 1250 divided by 3 is apparently 416, and we'll keep doing that and again. All right, and we're back at 1250. All right, and the next menu shows you the trigger value, and right now it's telling you that it's off. But if you turn it on, the trigger is currently set to about 1780 millivolts. Alright, and this tells you the LCD contrast. And again, if you press this button and this button here, where my thumb and my index finger are, you get single shot mode. And since there's a signal that's already going, it's just going to capture that, so I'm going to take that off. And yep, alright, so now we're back into the default screen, and let's get started showing you the signals. Alright, hopefully you guys can see that. As you can see right now, we've got a square wave, well, a kind of square wave going through the oscilloscope, and I'm going to enable the trigger on the Alto-scope right now. Alright, and I'm not sure if you can read that, but the Alto-scope is reporting the square wave is at about 7800 kilohertz, and I'm going to move the Alto-scope out of the way so you can see the frequency on the actual oscilloscope, and it's saying 7.7 kilohertz, so about 70 hertz off, which I think it's not too bad. The numbers you can see from the oscilloscope and from the Alto-scope are actually jumping a bit, and that's because the square wave generator isn't perfect. It's the Kit 23 square wave generator. I'm not sure if you guys are familiar with that. I'll probably do a video on that another day. And yep, it's reporting to us that the frequency is about 7800 kilohertz. And if you look at the plot itself, it's showing that it's about a 4100 millivolt amplitude. This is mostly right in that that's the maximum positive voltage. The way I have it set up right now is that we have a DC offset on the Kit 23 that's just built in. So I put a capacitor on the end of the output to kill that, and that has the function generator making a slightly negative voltage at the signal, so the Alto-scope can't display that, so it's only giving you the positive voltages, and that's fine. As we can see, it's still reporting back to us the correct voltage, and I'm going to pull that up on the actual oscilloscope right now. And yep, if you can read that, it does say 4.12 volts, and that is actually exactly on par with the Alto-scope. It's about 0.005 volts off, but I think that's a pretty reasonably close number. And let's take a look at the signal here. So at 7800 kilohertz, you can see that the time base on our oscilloscope is 100 microseconds. Actually, you can't see that because the camera's cut it off, but you'll have to... No, actually you can't see it. It's right over here, 100 microsecond divisions. That's what our Alto-scope is at right now. I'm gonna switch to that display so you can actually see it. Yep, time division 100 microseconds. And if you take a look, the square waves are just about the same size. I'm going to change the frequency on the kit 23 so that hopefully the positive edge of the pulse, the positive part of the pulse, the square wave, will take 100 microseconds to complete. I'm going to just change that right now. Hopefully I'll get it spot on the oscilloscope, then I can show you. Okay. Oh, it's almost there. Oh, a little bit over. Alright, turns out I'm not very good at this. There we go. That is fairly close. Now, I'm going to change the contrast on the display a bit so it makes it a little bit easier to see. There we go. Alright, so if we take a look over here, that whole pulse is roughly equal to 100 microseconds. And you can see on the Alto-scope over here where it's captured it pretty close to the divisions line. That is almost the same. So the scope is capturing at the right frequency. I guess it's a little bit jittery on the Alto-scope, and to me that's okay. But yeah, it's working pretty well. Let's change the frequency again and see if we can get it to take up 2 divisions. Hopefully that'll be a little bit easier to see. There we go. Yep. So as you can see on the Alto-scope and on the oscilloscope, that's about 2 divisions from the top. It's a little bit harder to see on the Alto-scope, but it's not aligned perfectly. But that's about right. Okay, and let's change the divisions so that we get 200 microseconds per division, and I'm going to switch that on the Alto-scope. Alright, and there we go. Now it's just about matched at 1 division on the oscilloscope and 1 division on the Alto-scope. So it looks like the Alto-scope's doing a pretty good job. And let's double check on that frequency counter. Alright, so it's reporting back to us 2300 kilohertz. Just about. It's jumping around between 2310 and 2340. The frequency counter on the HP oscilloscope is showing us about 22.7, 22.9. So it's about 40 hertz out, but I'd say again, pretty close. Okay, and at about this time my camera is getting warm, so I'm going to turn it off, take a little break, and then when we get back I'm going to show you sine waves, triangular waves, and then hopefully I'll get to show you the single shot mode with an actual, I guess, single shot signal that I'll be generating. Okay, so we're back, and now I'm going to change the signal to a triangle wave. Alright, as you can see, that is a triangle wave mostly. Gonna turn trigger on the Alto-scope. There we have it. Not sure if you can read that. It's definitely hard for me to read, so I'm just gonna change the contrast again. Alright. So, it's triggering fine, but as you can see, it's reporting back a frequency of about 2800 kilohertz, and the HP is telling us that it's more around 2300. And like I said in the first video, if you want this frequency counter to be any bit accurate, you really gotta have the counter in the middle. So I mean, you have to have the trigger in the middle. So we're gonna change that right now and see if that gives us any better results. Oop, that's up. Alright. Okay, so that's more or less in the middle of the signal. And you can tell right now that it is giving us a frequency of just about 2350. It's hard to see, and so I'm going to change the contrast again and see if we can make it any clearer for the camera to see. There we go. That should be better. Yep, you can see it's flashing relatively quickly, but it's pretty close. It's showing us that it is a roughly 2350 hertz, and that's about the same as we're getting on the HP. And so now we know that the triggering with the triangle wave works fine, and now we're going to switch on to the sine wave. Alright, so little thing here, the sine wave isn't actually a sine wave. On the K23, the sine wave is actually a pseudo sine wave. It's really the triangle wave that's being slightly curved. And again, the frequency counter is giving us just about 2300 kilohertz, like the triangle wave. I haven't changed the frequency at all, but let's speed that up. Okay, and now we're putting through roughly 7.8 kilohertz. Oh, and now that's 8 kilohertz straight. And if we can just adjust the trigger level. Oop. Signal died there a second, so let's do that again. Alright, so that's about right in the middle. Okay, so the signal isn't that consistent on the K23 function generator. As you can see on the HP, it's jumping around a lot, and it's also jumping around a lot on the Alto-scope. It's now showing that the frequency is about 8400 hertz, and it's jumping between that and 8500 kilohertz. And that's pretty off. As you can see on the HP, it's showing between 7800 kilohertz and 8300 kilohertz. So the signal isn't that great from this source. So how about we change sources and put back on a square wave at a much higher frequency. Hopefully the Alto-scope will be able to get that, and we'll be able to show you that it can properly sample a 1500 kilohertz signal, or 15,000 kilohertz signal. Alright, so I'm going to set that up right now, and I'll be back. Alright, so we're back. And as you can see, I've got a roughly 15 kilohertz signal going on here. And I turned the backlight on the Alto-scope, and then I realized it didn't really make a difference, but whatever, I'm going to leave it on. The Alto-scope is reporting that the frequency is just under 15 kilohertz. And the HP is kind of jumping around a bit because the signal is probably not 100% stable. But it's also reporting a number very close to that, about 14 kilohertz, 14.7 kilohertz to 15.18 kilohertz. So that's pretty close. And as you can see, it's plotting it pretty nicely. The trigger is on right now, and it's at 100 microsecond time divisions. And it just about matches up with the HP. And what I'm going to do now is actually going to speed up the frequency, and let's see what happens when we plot at faster frequencies. Oh, that's not faster, that's slower. Okay. So now we're going up to about 20 kilohertz. And you can clearly see on the Alto-scope we're not getting a lot of good samples. It's for every complete wave, it's just about 6 or 7 samples. That's not the greatest thing in the world. And now we're going to 30 kilohertz, and it's gotten pretty bad. At this point, it would be really hard if you had, say, like a triangle or sine wave. It'd be hard to distinguish it from just a single sample of data. But if we keep going, you can plot 100 kilohertz. It's trying to. It's not working. It's just not working. It's plotting signal on there, but you can clearly tell it's not plotting fast enough. And if we go even faster, it kind of just dies. That's 125 kilohertz signal, and everything's kind of broken down. The frequency counter is reporting that it's a 200 kilohertz, and it's kind of plotting a triangle wave, which clearly that isn't. Anyways, to bring that back down to a more reasonable number, you can see there's what I believe is aliasing if we go a little bit faster. Yeah, that's 77 kilohertz, and it's not looking good. But back down to 30 kilohertz, the Alto-scope can still distinguish square wave frequencies, kind of. And yeah, so there we have it. Run the whole thing through a whole bunch of signals. And for the last one, I'm going to just do a single shot signal, and I'm going to connect that onto another device that I made. And if I can find it. Nope, that's not it. Okay. I'm going to put it through this thing. It is a light sensor detector thing. It triggers my camera when a flash fires or when lightning comes on, or if something's blocked one of the light sensors. Anyways, that deserves its own video on another post. But anyways, that's what I'm going to use today to generate a single shot, and let's get that started right now. All right, so I've got both the HP set up to single shot mode. It's waiting for a trigger right now, and then I've got the Alto-scope also waiting for a trigger. Both are set to, well, the Alto-scope only has a rising edge trigger, but the HP is also set to rising edge. So what I'm going to do now is expose my little tool to light, and it should generate a pulse for us. Oh, there we go. Alright, as you can see, pulse was captured, and I realized that I haven't set the Alto-scope to the correct pulse duration. It's set still to 100 microseconds, and I know the pulse that comes out of my trigger is about 100, no, more than about 1,000 microseconds, I think. Actually, if you take a look here, it's actually, yeah, it's about 800 microseconds. So clearly I have had it set wrong. I'm going to just change that right now. Okay, so I've now set up the Alto-scope to trigger with a time division of 5 milliseconds. And let's see what happens. Oh, as you can see, we've got a signal. And that is broadly similar to the one that we've captured on the HP. I believe the Alto-scope caught it a tiny bit later than the HP. But that being said, I think the signal also isn't a perfect square wave. I think it blipped up a little bit and then down and then went back up again. But yeah, as you can see, the signal was captured on the HP and on the Alto-scope just fine, and it's roughly the same pulse width. I mean, roughly the same. Actually, yeah, pulse width. There we go. So yeah, there you go. Single shot mode with literally single pulse. Hope you guys enjoyed that video. Thanks for watching. I think next time we'll try to cover how you too can build your own Alto-scope in detail. All right. Goodbye.